Hello, I'm the Metagraphic Mr. Daycock, and today I am going to be teaching you about integration by parts. Now, integration by parts is effectively the reverse of the product rule for differentiation. And in fact, that's where we're going to start. So the product rule for differentiation tells us that if we have uv and we want to differentiate it, so uv dash, that's equal to u dash v plus v dash u. And now to reverse it, well, what are we going to do? We're going to integrate. So we're going to integrate both sides with respect to dx, and so we're going to get uv dash integrated with respect to x is equal to u dash v integrated with respect to x plus v dash u integrated with respect to x. And this allows us to work out how to integrate products. But it doesn't allow us with this bit. This bit here actually does something quite interesting. This bit is a derivative that is then integrated. And those are opposites. Those are the inverses of each other. So this bit here simply simplifies to uv, because we've undone this derivative with respect to x by integrating with respect to x. The other two bits remain the same though, so that's uv is equal to the integral of u dash v dx plus the integral of v dash u dx. And now to get our formula, our integration by parts formula, we actually want to work out an integral, so we need to move one of these across to the other side. And so we end up with u dash v dx is equal to uv minus the integral of v dash u dx. And notice that these are exactly the same, except which one is differentiated has been swapped around. And now this formula looks, quite frankly, more complicated than what we were dealing with. So we might be thinking, how on earth is this going to help? But this here is our integration by parts formula, and I'll show you in a moment how this is going to be incredibly helpful to solving the problem over here. Right, so we have the integral of u dash v dx is equal to uv minus v dash u dx. And now what we want to do, well, we need to think of it in terms of u dash, v dash. But notice that in our original formula, in the thing that we're going to be comparing to x sine x, we already have the u dash but don't have the u. Or you could write it the other way around if you prefer. It is of course symmetric about u and v. Now the question is, whatever we pick for u dash has to be integrated, and whatever we pick for v will have to be differentiated. Because we get to pick the u dash and the v, because that's what goes into our formula here, but we have to use the v dash and the u. So we want to pick something that is going to be nice to integrate for the u dash and something that's going to be nice to differentiate for the v. And the rule is basically which thing gets nicer when you differentiate it. So let's consider these. We've got our two options. We've got our x and we've got the sine x. If I were to integrate, x would go to x squared over 2, sine would go to minus cosine. If I were to differentiate, x goes to 1 and sine x goes to cosine x. So what you should notice here is it doesn't matter for the sine x. Doesn't matter which one I pick, because it's going to go into something that's effectively the same. The fact that arguably the negative is slightly more complicated, but it isn't really. Cosine x and minus cosine x are exactly the same level of annoyance in terms of differentiation integration. But over here, it absolutely does matter. If I get x squared, that's much more complicated than just 1. So the x, I want to go this way. And therefore, because the x must be differentiated, the sine x must be integrated, because I have to pick one or the other. Therefore, I pick the sine x as my u dash, and I'm going to pick the x as my v. I just wrote v then rather than x. And therefore v dash is 1, and u dash is negative cosine of x. And that is much nicer than picking the other way around, because otherwise I'd have ended up with an x squared, and then things would have been probably more difficult. And now it's just about a matter of substituting it into the formula. So our formula gives us u v minus the integral of v dash u dx. And now we just plug those in, and we've got them nicely listed out. So our uv is going to be minus cosine of x times x, and we're subtracting the integral of, well, v dash is 1 multiplied by sine of x dx. And that's not too bad. So simplifying the first term, we get minus x cosine x. And then this here is just another integral. We just need to evaluate that now. We just, well, deduce what we're going to get from there. And then we're integrating sine, and sine goes to minus cosine. So we're subtracting minus cosine of x. And so we end up with cosine of x minus x cosine of x, or 1 minus x lots of cosine x. And that is our integral of x sine x, with, of course, plus c on the end. And so our integral of x sine x is this. Okay, and that is how you use integration by parts. It is almost exactly the same as the product rule, except you need to remember your u dash you're picking so it integrates, and your v you're picking so it differentiates, and you want to really think about what's going to be nice to differentiate. Because if you get it the wrong way around, you're going to make things a lot more complicated for yourself. And then substitute and solve. Right, that's how we go at this one. Now here, hopefully we can see that e to the x is going to integrate or differentiate. It's going to stay exactly the same, so it doesn't matter. But x squared gets nicer as we differentiate it. So we're going to, when we go for our u dash and our v dash, we're going to want to differentiate the x squared. So we're going to pick v equals x squared, and so v dash equals 2x. And we're going to pick the u dash equals the e to the x, and therefore u is also equal to e to the x. And now we can just apply our integral. So the integral of x squared e to the x dx is going to be equal to, well, it's uv, so it's just going to be e to the x squared minus the integral of v dash u. So it's going to be 2x e to the x dx. Okay, brilliant. And now we just need to work this out. But hey, you might notice there's a problem. This is actually still the product of two functions. And so to do this one, we just have to use parts again. So we're just going to apply the parts formula to this again. And I'm going to pick exactly the same way. So let's go for u being equal to, well, we've got u dash, we've got v, and we've got v dash, and I'm going to pick the u has to be integrated, so I'm going to pick that as the e to the x again. And the v has to be differentiated, so that's going to be my 2x. And here I'm going to get 2, and here I'm going to get e to the x. And so carrying on with that, we're going to end up with the integral of x squared e to the x dx is equal to e to the x squared minus, and then we're applying the parts formula again, e to the x times 2x minus the integral of, and we need to go it the other way, it's going to be 2 e to the x dx. And notice I put the whole thing in brackets because we're subtracting all of this, because we're subtracting the integral here, hence we're subtracting everything here. And now it's just a case of simplifying everything, and we get the integral of x squared e to the x dx is equal to x squared e to the x minus 2x e to the x plus, because minus minus is a plus, plus 2e to the x. Or e to the x lots of x squared minus 2x plus 2. But if you're paying attention, that is not the answer to the question. The question was a definite integral with limits between 0 and 2, and so the next part is to plug in those limits. So now I need to remember to evaluate this between x equals 0 and x equals 2. And that will give me e to the 2 times by 2 squared minus 2 times 2 plus 2 minus e to the 0 times by 0 minus 0 plus 2. And that's going to be equal to, well, 2 squared is 4, minus 4, we get 2, so that's 2 lots of e to the 2. E to the 0 is 1 times 2 minus 2, and we get 2 lots of e squared minus 1. And so our integral is 2 lots of e squared minus 1 in this case. And that is our evaluation there. And notice sometimes after you've done the parts, you end up with another integral that you have to use parts on, but the key thing to check if you're going in the right direction is asking yourself, is it simpler? And in this case it is. Here we had an x squared, here we just had an x. It got better. And if it gets better, that suggests you're going in the right direction. Okay, last one. Now, look at this one. I'll take a moment, maybe even ask yourself, how are you going to integrate this with parts? You might look at this and go, and there's no product there. So maybe take a pause and have a go at it by integrating with by parts, because this is quite a nice one, and if you can spot the trick, you should be quite proud of yourself. Okay, so the trick here, and pause now if you haven't had a go at it yourself, the trick here is to write it as the integral of 1 multiplied by the natural log of x. Because integrating the natural log of x is supremely difficult, but differentiating it is really easy. So when it comes down to our question of should I integrate the ln x or should I differentiate it, you know you're picking the v as the ln of x. You're going to be differentiating that part. So we've got v, we've got v dash, we've got u dash, and what do we want to pick? Well, the u dash, if we pick that as 1, it will get more complicated, but it will get less more complicated than the natural log. So we're going to pick the natural log as the v, therefore v dash is 1 over x, and u is x. And so our integral of 1 of ln of x, let's just put it as ln of x, dx is going to be equal to, remembering that it's just 1 times ln of x, it's going to be equal to uv, so x ln of x, minus the integral of, and now this is u times by v dash, so x multiplied by 1 over x dx. And so this is x ln of x minus the integral of 1 dx, which is just x ln of x minus x plus c. And you could try differentiating it and you'd see you would get the natural log of x exactly. But one thing you should note is the natural log of x, if you integrate it, it gets horrible, not really your friend. So there you go, that's integration by parts. The part, for the most part, it's just substituting into the formula just as you would for the product rule, but remembering you need to pick carefully which one is your v and which one is your u dash. Okay, thank you for watching, and I'll see you in the next video.